Welcome back to the channel, fabricators. Today I'm going to be showing you how I go about installing a set of Trail Worthy Fab press wheel centers in some 16.5 Humvee bead locks. So first off, I want to say I'm going to be showing you how I do this, not necessarily how to do this. There are multiple different ways to go about this. Do your own due diligence, realize your skill level, and if this is a project that you should be taking on. The other thing I want to say is these Trail Worthy Fab wheel centers are an off-road application only. So take that into consideration if you're considering going this route with your vehicle. The main thing that you want to worry about is getting this thing in there flat and straight, because we don't want any runout. So what runout is basically if your wheel's spinning and it is doing this because your bolt face is not true to the face of the wheel itself. So I'm going to show you how I go about doing this with the primitive tools that I have in my shop. There's the most complicated thing that we're going to use today is a dial indicator. There's a couple ways that you could do this that would be even better, like checking these things up in a lathe, but I obviously don't have a lathe that is this large to be able to check these up in a lathe to check that run out. Or the other thing that you could do is tack these guys on, throw your wheels on the axle itself, spin them, and stick your dial indicator on there and check your run out that way. We're not going to be able to do that, so we want to make sure we get them as flat as possible from the beginning using a couple different techniques. So let's get started. So the first thing we want to do is get the wheel all laid down here. Like I said, our main objective is to get this bolt surface in a parallel plane to the face of the wheel itself. So what I like to do is take a file and just skate the edge of the wheel just to make sure we're free from any burrs or anything. Next thing we're going to do is flip the wheel over upside down and take our wheel center, drop it down into the back of the wheel, and mark around with our Sharpie or paint pen where that center is going to meet that wheel. And this is because we are going to want to grind off all the paint within about 2 inches of where we're going to be welding, because the top coating on these guys is nasty. You don't want to be breathing it. Another option, if you're buying these wheels directly from Trail Worthy Fab, is I believe they have an option to get them sandblasted, and I highly recommend that. So I got this guy all cleaned up. The best thing that I found is these paint stripping pads. I can leave a link to these in the description. And as you can see, we got this guy all cleaned up so that once it's sitting in there, there's still a good like 2-inch ring around here that's clean, and the main temperature is not going to get to that, burn it up and gas us out here. Then we're going to remove our wheel center, and we're going to remove our existing wheel center. So I'm going to be using a plasma cutter, and I'm going to use the back of the wheel as a guide to go around and cut this out. If you don't have a plasma cutter, what you're probably going to want to do is use the back of the wheel as a guide to make your mark, and then pull it off, and then carefully run that around that with your grinder or whatever you're going to be using there. Okay, so the next thing we're going to want to do, now that we got our ring all cleaned up, we got this all kind of deburred and as round as possible, we're going to take our back of our wheel, lay it back on top of it. We're going to take a rag and go and just kind of clean up surfaces where we're going to be welding. Don't want grease or anything like that. Then we're going to go over to our wheel center here. And these are not machined surfaces, they're just pressed units, so there's some deformities in them. And this is going to be harder to check if you don't have a flat table. So if you lay this guy down and you see which direction it teeters. So it looks like we're teetering the most in this direction. And if I follow it around here to here, we get the least teeter. So we'll find that direction that we're teetering the most again. So it's somewhere in this range. So I'm going to mark this side and know that in the deformity, my high side is going to be here and here, and perpendicular to that is going to be the low side. And that's going to be important when we stick it in here, because we know that we're not going to get the exact same measurement all the way around, because this thing is not completely flat. Now, it's not very far off, it's just a couple thousandths, but it's just good to know so that when you get that inconsistency, you can blame it on this part, not on you. So now we're going to take this guy, we're just going to place it in there on the back side. The next important thing to do is we want to be able to clamp this piece down in relation to the bottom face of our wheel here. So I have this nice fixture table that we're working with, and I'm going to just take this 5/8 bolt here and a stack of things that I've used in the past. So I got a sprocket that spans that hole and some spacers, and bolt this guy. So not to worry if you don't have a fixture table to bolt through. Another thing you can do is take like a 2x6 and drill a hole in it and run it up through the bottom of it. Just anything so that you are squeezing in between the bottom of your wheel here and this new wheel center that you're going to be in to hold everything down tight. So another thing that's going to be important is cleaning out this inner edge right here. This upper edge is sheared off, so it's not going to be super consistent. The most consistent thing I found to work off of is this inner edge, and then sometimes you can double check this upper edge, but these are further out, so you're going to get a more sensitive reading further out from the center. So after you get this guy all locked down to the table, you're going to want a couple of tools. First thing you're going to want is a straight edge so that you can run this along the top of the wheel here. And actually you want to make sure that all your wheel weights are off so that you don't have any interference. Like I forgot to pull this guy off. There we go. And run that straight edge along there. Make sure there's no burrs and that thing can lay flat. Next thing you're going to want is either a tape measure, a ruler, and or a dial indicator. I can leave a link in the description for one of these guys. You can pick one of these up for like 35 bucks on Amazon. They're really cheap, but I like the ones with the magnetic base. Then I can get this guy, drop it all down in here, and get a reading right off the edge of this and be within a couple thousandths. So when getting these guys dialed in, I try to shoot within 20 thousandths of runout. So that means I want 20 thousandths or less of runout. Now, like I said, some of these wheel centers aren't flat themselves. I've had some of them that had up to a 10 thousandths in difference just in the wheel center. So in some cases it's going to be difficult to do, but we just like to do the best job we can. The other thing that you're going to want to get is a punch and a hammer, and this is going to allow you to kind of tap this guy around and manipulate that and rock it into position. So I'm just going to go around with my ruler or my tape measure first, kind of get a average and get it roughed in, and then we'll go back over it with the dial indicator and fine tune it. And another thing that I'm looking at when I'm doing this is I'm going to be working in the coordinates of these marks that I use. So first I'm going to go back and forth in line with those marks because I know those marks are going to be more, quote, flat to each other because the wheel center itself was not completely flat. So we're going to check here and here in line with our marks, and then perpendicular to that here and here in line with our marks. Okay, so once you get this within a 30-second with your naked eye, sometimes you have to loosen this guy back up and rotate it to get it fit in the wheel the best possible way it can. Then I'm going to take the dial indicator, and there's two places that I found to work off of. They're best. I'm going to magnet this base right to my straight edge, and I'm either going to work off of this bolt face or down in the bottom of this groove. Okay, so what you're seeing me do here is I have the dial indicator set up on my straight edge, and then I've got it set right where this crowns over on the bolt face, and I'm just wiggling this back and forth, and we can watch the dial indicator spin. But the critical point is when it reverses direction. We know that's going to be the kind of the top dead center of that. So if we zoom in here, we can look at that and see that it reverses direction right around 10 to 11 thousandths right in there. It's going to vary between the chunks of dirt that are on there. So like I said, we want it to be within 20 thousandths. But then we're going to take the same thing and go to the opposite side that we were just measuring and check that side. So once you got this all dialed in where you should be, best thing to probably weld this with is a dual shield setup, but I don't have any dual shield wire with me right now. So when I don't have that, what I'm going to do is run a TIG root pass, and then we're going to go over it with our MIG. And when we weld this, we want to do it in quadrants. So I usually break it up into like little 3-inch welds. So at first I'm going to tack it in quadrants, and then we're going to weld it and do like 3 inches here, and then skip over and do 3 inches here, and then skip over and do 3 inches here, perpendicular, so you got 4 quadrants, and then we're going to move that in a circle and just do that step by step, so that as this thing heats up and it shrinks from the welding, hopefully it'll do it as evenly as possible, and we'll maintain those tolerances that we're looking for. Okay, so we finally got it all welded up. Your end result should resemble something that looks like this. What I do on these guys is I weld the back side entirely, all the way around. Like I showed you, we do our alternating patterns. So we go 4, 4, 4 in 4 stages. So we go there, 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 there. And then I come around to the front after that's cooled off for a while it's still bolted down. And I just stitch in between each of these legs here. So the front side is not fully welded, and there's lots of different opinions on that. The reason I do that is you're gonna get lots of strength by having that full weld on the back side, and then the reason I just stitch the front side is a couple reasons. Having it stitched and open on the front side is going to ensure that if you get water down in there and it freezes, there's less likely that it's going to expand and crack those welds out. And 2, if a crack does accumulate, having those stitches on the front side is going to allow that weld to terminate and not have a failure. If you have a continual weld on both sides, you run the chance that if a crack does get started, it can just continue on through that weld. Whereas if you just have it stitched, it can just go as far as that weld goes and does not directly affect the next stitch. So if you want to see more fabrication content, make sure you check out some of the videos that are going to pop up here. If you enjoy it, subscribe below and go build something, guys.